Hi, thanks so much for stopping by. My name is Karen Pierce, and I'm a professor in the Department of Neurosciences at the University of California, San Diego, and co-director of the UCSD Autism Center of Excellence. And I'm going to talk with you today a little bit about some of the exciting research projects we have going on in our center, and maybe you and your child can join, or at least you can learn about some of the new things that we're finding. Okay, the first study I'm going to talk with you about is what we call the SPARK study. And it's essentially a study trying to understand the genetic differences between children with autism and all of us, right? We all have around 20,000 genes in our genome. And there are just very subtle differences between each of us. And the SPARK studies basically collect saliva samples to try to understand what makes you, you, and me. So basically, we really understand at this point that autism is a strongly genetic condition. We know this because identical twins, which share 100% of their DNA, they're about 77% of the time when one child has autism spectrum disorder, the other child will also have autism spectrum disorder. But look at this number, it's not 100%. So that means that the environment also plays a role in the manifestation of this condition. And the concordance rate for just fraternal twins, so they do not share the identical DNA, is around 31%, which is actually higher than siblings, which is around 20%. And so fraternal twins, they're both twins, they shared a womb, they're born at the same time, they have more of a shared environment. So this is another clue why we think the environment plays a role in autism, because 31% is higher than 20%. They share the same amount of DNA as siblings, but there's a higher concordance rate. And I only have one slide, that's kind of technical about genetics. Basically, just to remind everybody that we have our genes, which are basically our DNA is basically our genes. And the genes are made up of these things called nucleotides. Remember, we've got adenine, thymine, guanine, and cytosine. And it's really interesting because there are around 3,000 nucleotides that make up a single gene. So let's say we have a gene for eye color, right? It's got all these letters like ATG, TAA, GCG. But if there's a change in even one of those letters, it changes what that gene does, just a single letter. And if you think about it like a sentence, right? This sentence says, Bob the cat cannot sit. If we change just a single letter, it says, if we change the C to a B, Bob the bat cannot sit. Now the sentence is completely different. And it's the same thing with your genes, right? If we change a single letter, the gene is doing something completely different. So that's kind of what we're interested in figuring out in the SPARK study. And how is SPARK going to speed up autism research? Well, it's actually an amazing study. The plan is to recruit 50,000 families that have a child with autism. And we're going to collect some information by questionnaires and figure out your child's genetic information through a saliva sample. And because, as I mentioned, autism is highly heritable, we want to also get a saliva sample for mom and dad so we can see how the genetic information is passed down a family line. Then it takes a while, about a year, for the saliva sample to be processed. But if there's a genetic result, your family is going to become informed. And around 10% of families actually have a positive result. And so you'll get a written report. You'll also get a free genetic counselor to kind of review with you what kind of special genetic finding your child has. And so you're going to get your genetic results returned. And then the Simons Foundation, which is supporting this research project, may contact you for further research opportunities. And the reason for doing all this, right, is because we want to move towards precision medicine. Right now, although the treatments for children with autism are great, they're mainly based on a behavioral model. They're not based on biology. And we really want to be able to tailor someone's genotype, like someone's genetic profile, and say, okay, you have this particular genetic profile. Maybe this type of treatment is better for you. So that's really the motivation behind this whole project. Right now, there are 31 research partners across America, with UCSD being one of them. And over 44,000 individuals with autism and 120,000 family members have already signed up. And as I said, we're trying to get to 50,000, so we need you to help. And again, we're returning genetic results to around 10% of families. And then these analyses are increasing the number of genes that we know are linked to autism. And when the study first started, the Simons Foundation puts out what's called this like gene list. And I'll give you the website for this. It just basically tells you all of the genes that have been found that are associated with autism that have been validated and replicated independently by different research laboratories. Because sometimes you might go to the internet and they, people will tell you, oh, this gene is associated with autism or that one. But this is a nice gene list because it really is vetted by scientists, and we look for replication. So other research laboratories have to find the same thing, and also a medical board, a review board, has to also endorse it before it would get on the list. And in 2017, there were around 78 genes that we knew were associated with autism. And today there's over 156. And if you're interested and you want to learn more about the genes that are associated with autism, you can go to this link, which is on the bottom of your screen. And if you want to find out more about what each of the genes do, so let's say you're over here and you're like, I don't know what ACTB is. What gene is that? You can go to this website and it will tell you what all of these genes do in terms of their function. Like maybe these genes are related to brain growth and development, or maybe these genes are related to vision function. So this will tell you. And it's really simple to participate. It's just spit in a tube. If you've ever done 23andMe, very similar. So you spit into a funnel, then twist off the funnel lid and you screw the cap on and you just pop it in the mail. And again, we're looking for saliva samples from the child on the spectrum as well as the mom and dad, so we can understand how things are linked in families. And we know that there are some children who might have a hard time spitting in a tube. So if you do sign up, it's completely online. You'll be mailed a kit, and they're like kind of like Q-tips type of swab things. And you can push that, depress that on the side of your child's cheek, and then get some saliva out from there. And then just squeeze it into the tube. And so this is kind of an alternative method for kids that might have a hard time spitting. And here's a little bit more of details about how you participate in the SPARK study. The first thing is you can just register online. Here's the website, sparkforautism.org/ucsd.sarc. SARC is one of our partners. And then there's going to be some consent forms. You consent to share your data. You can answer some basic information about your family. Then you can sign another consent form to the DNA analyses. And then your saliva kits will be shipped to you, and you provide your saliva sample, fill out some more questionnaires. And then again, if there's a finding, you're going to get your results returned to you. And if you have a particular finding, you may be asked to participate in a Simon Searchlight study, which is essentially nice because it groups everybody together that has the same genetic finding. So let's say there are 70 children that have been found and have a P10, a difference in their P10 gene relative to people who don't have autism. Then everybody gets together and they're trying to figure out, okay, what is this gene P10 doing? How can we help children who have this P10 profile? So it's really kind of a really creative and excellent way to move towards precision medicine. The benefits of joining are many. You receive a $50 Amazon gift card. Also, once you sign up for Spark, you have access to monthly webinars and newsletters. You get to participate in other studies if you'd like, but again, this is all online. Nobody's ever going to share your contact information. What will happen is Spark may send you an email saying, hey, Mrs. Jones, are you interested in participating in this study that's looking at sleeping habits? If so, we're going to email you some questionnaires to fill out about sleeping habits. And then, of course, you're going to get you potentially could get information about the genetics relating to your child, which is really important for medical health planning. You'll get a free genetic counselor if you get a result, and you can join a community and feel more connected with other families affected by autism. But most importantly, you can contribute to this historic study. I mean, as I said, there are going to be over 50,000 families participating, and we're already close. We're already up to around 44,000. So it'd be really wonderful if you're interested in joining us. And if you'd like to, you can go on the website that I gave you previously, but there are other ways. You can schedule a Zoom session with us. We can walk you through the registration process. It's online, so it's simple for us to do a screen share and help you through. You can just do it by yourself sitting on your couch. Or if you live in San Diego, you can call us and we can just do a driveway visit. Almost all of our staff have been fully vaccinated, so it's kind of nice that we can, have a little bit of, socially distant interaction and feeling a little bit safer at this point. Also, if you've got your phone, you can just open up your camera and scan that, and that will take you to a page that just asks you, do you want more information? And you can put your email address or your name, and then we can just contact you. Or you can register here. So this is our genetic study called the SPARK study. And here's a phone number too. So that's the first one I want to talk with you about. The second study I want to talk with you about is we're really interested in understanding the impact of when a child starts their treatment and what their school age outcome is. In San Diego, we've started an early detection program called Get Set Early, where we have worked with pediatricians. We've developed a pediatrician network of over 200 pediatricians in San Diego, and collaborated with them to have parents fill out a questionnaire when a baby comes in for well baby visits. And some children we've been identifying as young as 12 months, and we've been referring them for treatment sometime around their first birthday. And there are other children, though, who participate, who come to our center, who nobody noticed the first signs until the child was 3 or 4, so they're much later. And so the idea behind this study is we want to try to understand if the age that a treatment begins really does impact the long-term outcomes of kids when they reach school age, because everybody believes that this may be the case, right? Early intervention is key to great success, but no one's really ever empirically tested this to see if that's in fact true. So that's what this study is about. And here's just a quick conceptual model. This shows that there's an early screen, a child participates, and then there's a particular age that they get detected. And our theory is that very young detection will lead to very young treatment start, young family engagement, and it's going to positively impact child outcomes. But there are some children where this whole model for them will be older, right? They're going to have a later age detection, later treatment start, later age of family engagement, and a different outcome. So we're going to empirically test this by having children come to our center who have been identified at different ages, some super young, some a lot older. And they're going to participate in testing situations by licensed clinical psychologists. They're going to look at their core symptoms, their cognitive functioning, social and behavior, their language, their academics. Also going to ask parents questions about how they're feeling, how is everything going for them. We know that, of course, it's a really special situation for you to have a child on the spectrum, and we know that this can impact you in lots of different ways. And so we'll ask you some questions about that. And then we just have some information about trying to quantify your child's treatment engagement. And we do this again for kids who have been identified at all various ages in order to understand if age of identification and treatment start impacts school age outcomes. And to be part of this study, it basically requires you coming to our center for 2 visits. And again, it's a very comprehensive testing. So it's like 3 to 4 hours for each visit, but your child gets lots of breaks, and it's not like doing testing the entire time, but it's a 2-day visit, and all of our psychologists are licensed, and they're really very wonderful. And you'll receive a written report summarizing all of your child's test scores, which will be great for your IEP, great for treatment planning, but also maybe great for you to see how your child maybe has changed since they were 1 or 2, right? Children who are going to be in this project are between the ages of 6 to 10 years. So you can look back at your records when your child was a lot younger and see if there have been any changes and in what direction those changes have occurred. And then there's also a $100 gift card that you will receive for participation. And here's a QR code. Again, you can open up your camera. That'll take you to a page that just put your name and we can contact you if you'd like to participate. Or you can just call us at 858-534-6913 or email us. Or just go to our UCSD Autism Center of Excellence webpage. Anything you'd like. So that's really going to be an incredibly important project, not just for our San Diego kids, but really for the community at large and for the greater international community, just to really understand how treatment start and intensity impacts outcomes. Then the third study I'd like to talk with you about is our eye tracking study. For those of you in San Diego who may have seen me talk before, we really think that what a child visually attends to is really key for their early development. Because if a child is focused on faces and social interactions and is listening to language very early in development, this is going to help bootstrap and facilitate their later development. But there's a continuum, right? Some children on the spectrum have a harder time, and they don't have their attentional focus might be not always in the social world. They might be in other locations. And so we're trying to see if we can use eye tracking as a way to discover which children are on the spectrum relative to which ones are not at very early ages, like as young as 12 months. Again, because we want to identify children as young as possible and get them into treatment. So this particular study is for children between the ages of 9 and 36 months. So if you're a mom and you already have a child on the spectrum at home, but you're pregnant or you have a little one like a 1-year-old at home, then this is perfect for them. It's a really fun, simple study. It involves basically some testing and eye tracking. And let me tell you a little bit about why we're doing this. Again, we think that using eye tracking can help reduce the first age of diagnosis. We might be able to understand distinct biological subgroups because we know that there are a lot of, children on the spectrum are very different. Some individuals end up going to college and have great success. Other individuals might have more challenges, might not even be able to talk. So we think that there are unique biologies that kind of are going along with these different kind of profiles. We also think that we might be able to tell based on how a child examines things visually as a kind of what's called a prognostic indicator. That just means that you can tell based on a child's eye gaze patterns at age 12 months, how they're going to do 1, 2, or 3, or 4 years later. That's prognosing, right? Trying to understand the future. We also might be able to tell based on a child's eye gaze patterns what they might benefit from in treatment. So it might help for treatment planning. It also might be a good marker of treatment response. So for those of you who have never participated in an eye tracking experiment, it's super simple. Here we have just a schematic image of a baby. It looks like the baby's just watching a movie. And in our research project, the baby's just sitting in their mom's lap. And there's a movie that appears on a screen. But on the bottom of the screen, there are these kind of infrared light beams that project out from the bottom of the screen. They're naked to the eye. We can't see them, but they're there. And it casts a light or a glow onto the baby's cornea. And this reflection is read back into the machine. And it's sort of the angle that the reflection is read back in that tells us the point of gaze. It tells us where the baby is looking at on these movies. So it's considered like a corneal reflection technique. And then there's mathematical models that tell us exactly where the baby is looking. So that's how it works. And with most eye tracking studies, we try to capitalize on the fact that babies are really interested in social images from the second that they're born. This is one of my favorite studies. It was performed by Gorin in 1975 and replicated by Johnson in 1991. Basically, a mom has just had a baby and the baby's 9 minutes old, and researchers kind of bust into the room with a paddle, 3 different paddles, one that has a smiley face on it. One paddle has just these components of the face scrambled, and then the other one's a blank paddle, and they put the paddle in front of the baby's face and they just move it around like that, and someone's videotaping the whole thing, and they add up the amount of time the baby looks at the paddle with the face or the scrambled face or the blank face, and the baby actually spends more time tracking the paddle that has a face-like pattern versus the scrambled pattern or the empty pattern. So by 9 minutes in age, the babies are already kind of interested in faces. And when we kind of look at brain imaging data, this is a study by Ferroni in 2013 using functional NIRS. Basically, this shows that when the baby is looking at this human face, there's a lot more kind of changes in blood flow and a hemodynamic response on the right side of the brain in response to these faces. And when the baby is looking at these kind of objects, you're not seeing the same level of brain activity. So the brain is really responding at a young age to faces. And so what we did was we developed an eye tracking test called the geometric preference test for autism. And I want to show you what a real eye tracking test looks like. Here, I'm going to play for you this 1-minute movie that shows you the data from a typically developing 14-month-old. And he watched this movie, and the red dot shows you where the baby was looking during this eye tracking task. And with eye tracking, the size of the dot tells you if the baby is staring. So if the dot gets really big, that means that his fixation point hasn't changed. And so the dot just gets larger and larger and larger. And here you can see that he's kind of looking on both sides, but he's spending more of his time on the side that has the children doing these movements. And that's a lot of staring because there's like a big red circle there. And now now I'm going to show you a child on the spectrum who is 15 months old, and you see if you can tell a difference in what his visual patterns are and kind of what image he prefers to look at. So if you have your child participate in this project at our center, they'll be watching about 7 or 8 movies. And you can see here, this child really liked these geometric shapes, these dynamic geometric images. And each of the movies are only about a minute long. So the entire eye tracking battery takes around, there's like what's called the calibration in the beginning, but around 15 minutes to do the eye tracking. So you probably notice a difference that the child on the spectrum really liked the dynamic geometric images and didn't look at the social side very much. And the child that was neurotypical had the reverse pattern. But what's interesting about these results that I love is here's the data. So this is like the only kind of detailed data slide that I'm going to show you guys. But the way you read this is here on this, what's called the y-axis, it tells you the percent of time that the child is fixating on geometric images. And remember, because it's side by side, so you can only be looking at one place at one time. So if a child is looking at the geometric images, let's say 90% of the time, the way you read this graph is then you know, oh, he was looking at the social side 10% of the time. And the flip is also true. If the child was only looking at the geometric images 10% of the time, then that means he was looking at the social images 90% of the time. And here on this bottom axis, this x-axis, is all the different children based on what their diagnostic category was at the time of, actually at the end of the study. And we had 269 children that were on the spectrum, 39 that were showing some features, 80 that had a developmental delay, 178 children had a language delay, 100 children had some other issue, 212 were typically developing, and 39 were siblings. They were typically developing siblings who had a brother or sister with autism at home. So we call them TIP-SIBs. And what's great is you can see children with autism. Here's a whole range. Some children with autism looked at the geometric images a lot, like some almost as much as 100%, and they completely ignored the social images. But look at this here on the bottom. These kids down here, they looked at the geometric images barely at all. They looked about the same amount as all the other kids. They were just the same as the typical kids. So there's this grouping. And if you draw a line at a 69% fixation mark, you can see that it's mainly the children with autism are looking at the geometric images more than 69%. So this is kind of one of the steps we do to try to discover biomarkers. We say, hey, if a child looks at geometric images 69% of the time or more, there's a really high chance that they're on the spectrum. And if you can do this test, let's say with a 12-month-old, you might be able to detect autism a year or two earlier than maybe somebody else would notice it. And we've replicated this study in a couple of different journals. And here, just to give you a more detailed look in the data, there were 61 children with autism, what we call true positives. So they looked at the geometric images 69% or more. And out of 648 contrast kids, only 14 looked at the geometric images 69% or more. So clearly this is something that is associated with autism. And when you look kind of at these validation statistics associated with this test, sensitivity is 23%. That means that this eye tracking test can detect around 23% of children on the spectrum accurately. And specificity is 98%. Positive predictive value is 81%. Negative predictive value is 75%. That's using the 69% cutoff. And we also looked a little further and found that children who performed in this extreme form on the eye tracking test, children who looked at the geometric images 69% of the time or more, they tended to be the kids that had more symptoms, so increased symptom severity as based on the ADOS, and worse language scores, so a reduced language ability based on the Mullen scales of early learning. So that's the eye tracking study. And if you're interested in participating, you just have to come to our center once for testing. Again, the eye tracking battery takes around 15 minutes, but then we need to understand more about your child. So we'll be doing some other evaluations like the ADOS and the Mullen, and we block off 3 to 4 hours, but your child gets breaks and it's not really that much time for testing. And we will give you a written report with your child's test scores. It's really fun. And we also can do replays for parents so they can see their child's eye gaze performance. Once the test is over, you can see how your child did. So it's kind of a fun study. And here's a QR code for that study, or you can call us directly. And so with that, I want to thank our funding agencies, the National Institute of Mental Health, National Institute for Disorders and Communication Disorders, Simons Foundation, the Centers for Disease Control, ACEs. And here's our phone number. Thank you. Bye.